A warm welcome. As a part of the course Microprocessor and Microcontroller, we are here to present our project on the topic Traffic Collision Warning System. The project is submitted by Rahul Vijayakumar, Nandana V, and myself, Nandana Sabu. Introduction. Traffic control has a great importance in the lives of all the people. A traffic control system realizes safe and smooth road traffic flow. Based on the analysis and simulation results of the traffic information gathered by various detectors installed along roads, the system, for example, controls traffic signals and provides traffic information via various media to realize the traffic management optimal for cities and the environment. We have designed a traffic collision warning system using an ultrasonic sensor. The system transmits traffic events which are not directly visible to the driver or which the driver may fail to detect. It provides the driver with such information as necessary in order to reduce traffic accidents. Signal recognition enhancement system, rear end collision prevention support system, right or left turn collision prevention system, etc. Let's see the objective of our project. We intend to develop a prototype of our project traffic control warning system, which can be installed in the roads and highways and will help in reducing accidents on the road. With the help of an ultrasonic sensor in the vehicle, drivers can detect any barrier or obstructive on the road. This real-time project helps to detect collision and acts as a warning system for the drivers to be cautious and safe on roads while traveling. Thus, the objective of this project is to provide collision prevention warning system on the vehicles to provide road safety for the drivers. Methodology. This is an Arduino-based collision detection warning system. This kind of system is the fastest growing safety feature in the automotive industries. Such a system enables vehicles to identify the chances of collision and give visual warning to driver so that the driver can take necessary action to avoid collision. This project idea is based on an Arduino controller, and the whole project will give you a very good understanding of how this system works. The step-by-step method is explained so that you can make the system. The hardware connection, pin information, and Arduino program is explained clearly. These are the required items for the making of our project. Arduino board, HRSC04 ultrasonic sensor, computer, cable, wires, and two blue LEDs. Let's learn more about Arduino and ultrasonic sensor. What is an Arduino? Arduino is an open source platform used for building electronics projects. Arduino consists of both physical programmable circuit board and a piece of software or IDE that runs on your computer used to write and upload computer code to the physical board. The Arduino platform has become quite popular with people just starting out with electronics and for good reason. Unlike most previous programmable circuit boards, the Arduino does not need a separate piece of hardware. In order to load new code onto the board, you can simply use a USB cable. Additionally, the Arduino IDE uses a simplified version of C++, making it easier to learn to program. Finally, it provides a standard form factor that breaks out the functions of the microcontroller into a more accessible package. Let's learn about ultrasonic sensor. It's an instrument that measures the distance to an object using ultrasonic sound waves. An ultrasonic sensor uses a transducer to send and receive ultrasonic pulses that relay back information about an object's proximity. An HC-SR04 ultrasonic distance sensor actually consists of two ultrasonic transducers. One acts as a transmitter that converts the electrical signal into 40 kHz ultrasonic sound pulses. The other acts as a receiver and listens for the transmitted pulses. When the receiver receives these pulses, it produces an output pulse whose width is proportional to the distance of the object in front. Since it operates on 5 volt, it can be connected directly to an Arduino or any other 5-volt logical microcontroller. We have gathered the following items for the making of our project. Firstly, a computer is required to write the program and flash the program to the controller. Also, you need to install Arduino IDE, which is available freely at Arduino website download section. We have used an Arduino microcontroller, HCSR04 ultrasonic sensor, two blue LEDs, as well as the jumper wires, which are required to connect the hardwares. The devices we have used to make the connections are also given below. Hardware connections. The sensor has 4 pins: the VCC, trigger pin, echo, and ground. VCC pin is connected to 5V on controller. Ground pin is connected to ground on the controller. Trigger pin to pin 7 on the controller, and echo pin is connected to pin number 4 on the controller. The blue LED has 2 pins. We should connect one pin to the pin number 13 on the controller, and the another pin is connected to ground on the controller. You have a USB data cable that you get with buying the Arduino. With this data cable, you connect the computer to the Arduino board. Now, launch the Arduino IDE. After connecting the computer, you must select the board and port from the menu. A schematic diagram using the Tinkercad software is shown below for your reference. This is the software program. Let's see how the system works. Let me explain for you how this system works. I defined 3 different zones: Zone 1, Zone 2, and Zone 3. In Zone 1, no warning is required as you are safe. In Zone 2, we get a visual warning where one LED will blink. In this zone, the driver has to pay attention. In Zone 3 also, we get visual warning, but here both the blue LEDs will blink. Here, the driver has to take necessary action to avoid collision. Look at the images carefully. In the first diagram, you can see that the vehicle is traveling in the zone 1, which is safe. Hence, no warning is required. Thus, our LEDs are not blinking. If you look at the diagram 2, the car has entered into the zone 2, where a warning signal comes and the driver has to pay attention. Here, one of the blue LED will blink as a warning signal. Now, in this diagram, the car is approaching the zone 3. That means collision can happen or it is unavoidable. Thus, the driver needs to be careful and necessary action should be required to avoid the collision. When the car is going to enter the zone 3, both the LEDs will blink as a sign to show that necessary action is required to prevent the vehicles from colliding. Hence, the driver has to be alert. The image of the LEDs have been attached for your reference. Let's move on to the result. The project Traffic Collision Warning System using Arduino was designed and has found that the designed hardware and software has shown consistently faithful readings and also proved to be accurate. The hardware result and the software result, the images have been snipped for your reference. I hope you have seen our result carefully. Now, let's move on to the conclusion part of our project. In this project, we proposed and implemented the collision prevention system. The basic idea behind this project is to avoid collision and for detecting the obstacle. It is a precautionary measure that alerts the driver. The initial stage begins from the ultrasonic sensor that identifies the vehicle in front and backside. At 20-meter distance, one blue color light alerts us. When it reaches below 10-meter distance, both the LED's blue lights will alert us that we are in danger zone and take necessary action to avoid collision. At the same time, the distance between one vehicle and the other will be displayed on the screen. The wire connections are made from the Arduino board from the breadboard to the Arduino kit and to the ultrasonic sensors. This project will make easy calculation of the distance between one vehicle and the other for the driver. Using this system, we may avoid many accidents on the road. The system comprises of very low-cost components such as the ultrasonic sensors, LEDs, etc. Thus, we have come to the end of our PowerPoint presentation. Now, let's move on to the working and simulation video of our real-time project. Thank you.
So this is a collision warning system made using Arduino. This is going to be implemented on the back of the vehicles. So first, when there is no collision, these LEDs represent the indicators in the driver's cabin. So now the LEDs are off because the indicators are off because there is no collision. Now imagine that this is an approaching vehicle. As the vehicle approaches the car, one indicator will start blinking. It shows that the collision, it's a collision warning. Collision is not yet unavoidable. Collision can be avoided. Apply brakes. It will instruct the driver to apply the brakes. But if the driver hasn't applied the brakes and the subject is getting closer, now at this point the collision is unavoidable. So both of the indicators will flash in the driver's cabin. It will show that the collision is unavoidable. Even if you apply the brakes now, the collision can't be avoided. So it will instruct the car's airbag computer to deploy the airbags immediately. It will also ask the driver to brace to reduce the impact of the collision. This project has been made using an ultrasonic sensor which is connected to the Arduino. These indicators are also connected to the Arduino. We use C programming to program the Arduino. So it will measure the distance. And for now we have set it like 20 centimeter. So your distance is 20 centimeter. Distance between the behind vehicle and the car is 20 centimeter. It will provide the warning. And if it keeps on coming closer, like the distance goes less than 10 centimeter, it will detect that a collision is unavoidable. And this can be scaled up to real world distances. Now this is just a small prototype, that's why it is centimeters. So that's it. Now we will explain the working of the automatic collision warning and avoidance system made using this Arduino and ultrasonic sensor. So this is the ultrasonic sensor. The sensor has 4 pins, VCC, ground and 2 data pins. The VCC is connected to the 5-volt pin of the Arduino and the ground is connected to the ground of the Arduino. These 2 pins power the sensor. And then the 2 data pins, they are connected to the port number 6, pin 6 and pin 7 of the Arduino. The Arduino has been loaded with a C program which measures the distance between the object in front of the sensor. So this thing will be implemented on the back side of a vehicle. So it can measure the distance between the vehicle behind the car. So once the distance is less than 20, this 20 can be scaled up to the real world measurement. For now it's a small prototype, that is why we are setting the distance as just 20 centimeter. Once it detects that it is on the range of 20, and it will sign a collision warning system. This is a collision warning indicator. Now you can see that the collision warning indicator is blinking. It is just one indicator. It is collision warning, and it will also send a serial output that the collision is warning. Apply brakes. Now as the object is getting closer, both of the indicators are blinking, which shows the collision is unavoidable. Deploy airbags. These indicators are connected to the pin number 2 and pin number 13 of the Arduino. Pin number 2 and pin number 13 of the Arduino. We use C programming to enable both of those pins depending on the condition. That is the distance between the vehicle behind. And then also the Arduino sends the data to be displayed through serial output to the display here. You can, when it is practically deployed on a vehicle, inside the cabin of a vehicle, we can connect it to the screen of the vehicle's cabin or a separate external screen to display the warning to the driver. And this will be also connected to the airbag computer of the vehicle so that we can send a message to the airbag's computer, deploy the airbags when the collision is unavoidable. This is the practical use of this project, and this is also the working and the construction of this project has been explained here. Thank you, sir.